Um, had to stop the recording for the recording for those who watch it later. There was something wrong with the network. Somehow we got frozen. I think a lot of people in the room got the same. So anyway, what I was saying is that evaluation takes time. It's tedious. You make a mistake, you have to start over. Uh, and so there's techniques to do it right, but like it's expensive. Real evaluation of visualization that that really looks at the people. It's more or less like a psychological test at the end of the day. And I know the kind of the rest of the chapter, we'll look a little bit at the data. So we talked about why visualization works. We look at kind of the human very, very quickly. It's not the psychology class, so there's probably quite a lot of things that are applicable on the human side that I'm not covering. I may not even be aware of everything. But now let's look at kind of from the technical side, what is, how is data supposed to look like for this kind of what's the process? I know we had this discussion, and maybe I skipped because I knew I had this slide, but I don't know where data ends and information begins, and knowledge. Dr. Talbot says knowledge. Then what do we have? Enlightenment, and then nirvana. So all of these are, but just data and information. If somebody can give me a definition of the data and a definition of information, I'll be able to maybe judge when one begins the end and one ends, but there is no good definition. So if you call it data visualization or if you call it information visualization, it's about the same thing. Data quality, information quality, about the same thing. We're kind of looking at things that, some information that we look for.
CMS book.
I'm not using that book, and it used to be a book that I used, and I stole this picture from it. So
That's why I was curious.
it was actually a collection. It just had an introduction and then a collection of articles, but it's gotten old quickly. But in general, I think we start with some sort of raw data, whatever that means. But we start with data. And again, I don't know what difference between raw data and data is. We start with it. We may have to do some transformations to put it in a format that the software will take it. It's not a human thing necessarily, but one way that the software will kind of take it. And then from this data, we're going to come up with some sort of visual structure. So here there's, I think chapter 3 of the book kind of talks more about this. Call it visual encoding. We encode the data that we have here in some visual format. And normally we should have, you can have an artist do it, but then that doesn't mean that there is a clear mathematical thing that you can replicate it. Normally in information visualization, we have this process. We have this process here done by computer. It's replicable. You add different information, then there's a different visual encoding that comes up with. So we may make up visualizations. And then we can look at different views of that data once we encoded it, once it kind of have a shape now and a color. And the simplest way to think about it, I can scroll through it. I can, zoom in and out and pan left, pan right, if it's a picture, if it's 2D. So that's kind of the view. That not necessarily changes structure. So the user kind of looks here, and then they have to perform a task. You can think of it as performing a task or solving a problem. I think both are almost different coins of the same thing. And if the user is happy, then we're done. If the user is not happy, comes here and kind of zoom in or zoom out or look in a different place in the picture. If that's not good enough, they may change how information is being shown. And if that's still not good enough, they may bring in more data or transform what they have, derive a new attribute, and kind of go through the process. So that's kind of how this kind of comes in. And I guess if you see here, they say It's more of a database view or information view, because the difference, according to this, between data tables and raw data is I have some metadata, what that means. So some description. Raw data is, I don't know, it's just coming through the door. I don't know what it is. And we'll kind of spend lecture 2 on we're going to start lecture 2 with this, spatial substrate marks, graphical properties. But before we get there, let's talk a little bit about types of data and this is a very high level view, but in general, and it applies to visualization, it really almost applies to statistics and a little bit to machine learning. So what kinds of data can we look at? So one of them would be nominal, some people call it categorical, but it's just names. Chrysler, Ford, Mercedes, or horse, cow. So it's just names. There's no relationship necessarily between nominal data. In other words, if we go to ordinal data, then we have a relationship in the sense of a greater than, smaller, or before or after. Here's an example of ordinal data. Monday, Tuesday, Wednesday. We know that Monday is before Tuesday, and then Tuesday is before Wednesday, and so forth. Their names, yes, but you can put them in order. And then the last type of data, it's your numbers, and it's quantitative. So we can do math on it. It contains intervals. We can talk about 4 is twice as big as 2, and then 6 is 3 times as big as 2. So we can talk about these kind of things. So that's quantitative. So those numbers not only you can order them, but there's something in between. In Monday, Tuesday, there's not a Monday and a half, or a Monday 0.3. So that's kind of the thing. Now all of these things, the analysis and maybe the way people think about them, like I said, we can think of Monday and 0.2, is that sometimes it makes sense, sometimes it's not, but to kind of figure out things to assign to different types of, how do we represent nominal data? How could we represent it so we don't show an order? Different visualization techniques, sometimes some visualization techniques do impose an order on them. So if I have a bar chart and I show, number of cars sold by Ford, GM, and Stellantis, because the way a bar chart works, one of them would be on the left, the other would be on the right, and there'll be one of them in the middle. So I'm kind of showing a little bit of it's not my intention, and maybe people don't mind. But what I'm saying is sometimes if you're a purist, some visualizations may show something that's not there, i.e. order, or maybe interval or something. So what I have here, kind of a what if scenario, but it's not that important. But if my only chance is I have circles, square, triangles, and stars, they have the same color and they're the same size, what kind of data would I represent? Would be best represented by them? And it's probably nominal because there's no order. It's not like the triangle is before square or the circle is before star. So they don't tend to not have an order built in. But like I said, it all depends. Everything gets more complicated as we build up visualization. So that's just, at a first glance, it kind of feels like it's like that. So that's one way to look at the data, is what do we have inside of it. The other is to look at how it's organized, how it's stored almost. And for the most part, all of this comes almost from the kind of database world, so table databases and so forth. And if you know anything about them, you know that databases, they want to have the same number of columns. They kind of, all the operations, they don't like to add new columns. It's expensive, especially if you have already 1 million records and you add one more column. How do you update? You need to update 1 million other. And then the records, what I meant by records is going to be the rows. So it's kind of a tabular format. This format also, very useful, again, for statistical analysis. Some tools would take it easily like that. Even machine learning, so it's a pretty popular format where everything is broken down by columns, and then we have rows. And in a way, we think that columns are static, and then the rows can vary a lot more than the columns. Some buzzwords here. This data has 4 dimensions because it has 4 columns. 4 columns, 4 variables, 4 properties. So variables, if you're doing statistics, you say, oh, we have 4 variables. And all that. That's different ways from different fields to refer to it. Attributes, I think it's not put in here. It has 4 attributes. And then the size of the data is 3. And then we can have all kinds of data. Some of it may be large. When we talk about a large data set, we normally mean lots of rows. It may be just a single column. Like, again, the stock market performance from just S&P 500 every day or every minute since 1970. That's a large data set, but it's just one number, one column. We can, normally when we say complex data, we mean data that has a lot of columns. It may not have a lot of numbers. Text, the way text gets processed, even by neural networks and so forth, it kind of gets processed, it gets vectorized. There's a different name for embedded. They create an embedding, so text becomes a high dimensional thing, 200, 300, 400 dimensions for each word or something like that. I may not have a lot of words, or for each document that we'll remember it. So that's an example of that. But we can have data that is complex and maybe not have that much size. Or we can have a data that has both. Lots of columns and lots of hundreds of columns and tens of thousands of rows. How do we visualize that? Well, I don't know. Like I said, there's ways to do it, and we'll kind of keep talking different types of data. But that's one thing. Every time you look at a visualization, say, how many rows can I handle? Can this type of visualization have? How many columns can this type of visualization have? So the size and complexity is always something can be in the back of your mind, looking at it. Okay, so as the slide here says, there's also improper ways to have the data. They're good for a person, we understand them, and there's actually pieces of software that could maybe deal with them, but it's not a universal way to look at all the pieces of software that we have. They may get confused on this type of data. So on the first one, what's wrong with the first one? Well, first of all, the number of columns is not constant. We have this row here only has 1 column and kind of splits, and then this row here has another column. And people understand it. And it may be a good visual way to look at it in the tabular, just like tic-tac-toe in a tabular format, may be good. But really, how would I fix this if I were to put it in a format that is readily accessible, kind of look for analytics and visual analytics and visualization. So to fix this, I would keep these 4 columns and I would add another one, something like, let's call it place. I don't want to write continent because it's really hard to write with the mouse. And then, so this row goes away. This one goes away. And then I would add North America to that row, North America. Notice that I'm repeating For every country, I have to repeat it in the original improper format. I only wrote North American ones. So again, computers and analytic tools and visualization tools don't care. As long as we're dealing with, they actually do better this way. And then Brazil is going to be South America. So we end up repeating stuff, but it's the proper format. So in fact, this data set has 5 columns, so 5 dimensions, and 3. The size is 3, looking at it. So that's one. The second, the one, again, these are two, you can find a large number of it. People can think of different ways of destroying the normal tabular way. So that's one way that's typically there. Another way you would find it here. So let's say that's temperature taken in Little Rock. So at 12, it was 84. At 1, it was 86. At 2, it was 89. In Benton, that's a small city next to Little Rock. 12, it was 82. At 2, it was 85. And that's it. We don't have any more information about that smaller city. So again, the problem here, again, variable number of columns. And that kind of doesn't tell me, how would I fix this? I would probably need to, let me switch colors. Since that's green, I'll go to green. So I would probably have a column to have the city, column to have the time, and a column to have the temperature. And they kind of look the same, but in mouse writing. So the city would be Little Rock, time would be noon, and temperature would be 84. And then also in Little Rock, at 1 is 86. Little Rock at 2 is going to be 89. Again, I end up repeating Little Rock, but that's fine. It's a computer format. Benton at noon is 82. And then Benton, at noon, yeah, I said that, at 2 is 85. So really this data set has 3 dimensions and it has 5, the size is 5 for this data set, if I rewrite it in the format. So for the homework, or for if you have data in one of these non-standard formats that you run into, you may have to process it a little bit. Some of this can be done in Excel if you are, medium proficient with it, or some other way. You don't have to write code necessarily, but obviously if some of you know Python and you can do pandas and NumPy, then you can reprocess data anyone you want, reorder it based on different things, and so forth. And I think that's the last slide that does it. It always gets converted the wrong way. And before I end this lecture, let me pull up that PowerPoint and show you that last slide. It's coming up, hopefully. And let's see, share screen. Share. So I just pulled it up in PowerPoint directly. This is, it's not exactly what's shown in that visualization, but it's something like that: income, tax, population, and maybe even area of the country. Again, this is obviously computer generated, but it was originally created and shown to the British Parliament, so it was hand drawn before computers. Was just.
When you're ready, there's a new little muffle cap to put on his neck.
Thank you, Liz. So it was, and what it shows here is how hard it is for people in Britain. So what are we looking at? And you can see population is shown right here. And then tax collected is shown right here. And then probably this is geographical area. Again, geographical area, geographical area, geographical area. And the point he was trying to make is that in the Russian Empire, it's easy, you go down, they don't collect too much tax. In the Turkish Empire, it's easy, you go down, they don't collect too much tax. In the British Empire, you have to go uphill because they're collecting too much tax. In France, kind of the same way. So that's kind of the point. Now, if I rescale these, I can change. If I try and rescale, it can probably change the slope. It all depends where do I start, how high do I go with the taxes. But that was the idea there, to communicate. Finally, visualization is common activity everywhere. You watch the Super Bowl, there would be a visualization. Yes.
The one for Britain and France, it's the same information, it's just written or drawn backwards, so to speak, right?
Well, probably the population is larger. So the population and then the tax. Yeah. Right. No, it's not the same information. So this is population. It's not quite the same, even if you look at the numbers.
But it's showing that the more money you make, the more taxes you pay, right?
No, it's not the money, it's how many people are there. Basically, they're saying Britain collects so many taxes from so few people.
I'm sorry.
So this is the number of people. A lot of people, few taxes. A lot of people, few taxes. Britain is not a lot of people, but almost the most tax. Well, maybe the most tax of all these empires. Okay, so that was a question I had from the audience. But here, that's the last slide, and I'll finish. So again, if you look at the Super Bowl, there's visualization. I know there's video, but they show you some things as simple as the score. They will show you how many timeouts are left. All of these, any sporting event. Nowadays, they even put yellow lines on the court to kind of tell you how many yards they have. And they have visualization everywhere. Our cars show visualizations. Our phones use visualization. So it's everywhere. It's very pervasive. And some of these techniques that I have kind of the original here or in the slides, and I talk about them, some of them are almost seamlessly integrated now with a lot of, you would even consider it common sense. Right? But in the beginning, people didn't know how to display all of that, like file system, how to display everything that we use on a phone or in a car. It's a different kind of data and visualization. And then the other thing is, hopefully, I talked a lot about how visualization, and that's going to be the project. I'm going to be like a one-string banjo on that. What's the task? What's the task? And then the design of visualization is not trivial because we're dealing with people. They're as complex as people.